You know, your AI is a genius. It can write poetry, it can solve incredibly complex equations, it can even write code. But what if that genius is trapped? What if it can't actually interact with the real world? Well, today we are unlocking that cage with a really powerful key, the Model Context Protocol, or MCP for short.
Just imagine for a second that you have the smartest AI on the planet. I mean, truly brilliant, but it can't check your latest GitHub commits. It can't read a new message in Slack. It is a genius, but it's stuck in a digital box, completely cut off from all the real-world tools that you and I use every single day. Now that is the exact problem we're here to solve.
So, to really get our heads around this challenge, we need to meet the two main characters in our story. First up, you've got the host. Think of this as the AI's brain, the chatbot you're actually talking to. Then you have the server. Now the server is the outside world. It's the tool it needs to access, like GitHub or your Google Drive. The big problem? They don't speak the same language. So how in the world do we build a bridge between them?
Well, the first attempt at building that bridge is, let's just say it's a little clunky. I mean, take a look at this 7-step process. You ask a simple question, the host then has to go ask the LLM. The LLM figures out, hey, I need an external tool for this, so it tells the host to go talk to the server. The host goes and gets this big pile of raw data, but it has no idea what it means, so it has to go all the way back to the LLM to get it interpreted before it can finally give you an answer. It's this long, inefficient round trip just full of back and forth. Sure, it works, but it's kind of like sending messages by carrier pigeon in the age of email. We can do way better.
And this, right here, is where our hero enters the scene, the MCP client. I want you to think of the client as this brilliant intermediary, a kind of universal translator that sits right between the host and the server, making their conversation totally seamless.
The client's real superpower is its fluency. It speaks the exact same language as the server. And what that means is the host doesn't need to get bogged down on all the messy technical details anymore. It just makes a simple request, and the client steps in and acts as a perfect translator, handling all of that complexity behind the scenes.
And you can really see the difference side by side here. The old way, on the left, it's this tangled direct connection. But the MCP way on the right, it's just so clean and elegant. The client sits right in the middle, simplifying everything for the host, and this is the really important part, decoupling the systems. They're independent now, not some tangled mess. Here's a great way to think about it. Your host is like your phone. The server, that's the network, like AT&T or Verizon. So what's the client? That's the SIM card. And you need a specific SIM card for each network you want to connect to. This means that the relationship between a client and a server is strictly one-to-one. And this design, it unlocks two really game-changing advantages. First up, safety. Because everything is decoupled, if your connection to one tool, let's say GitHub, breaks, it doesn't bring the whole system crashing down. Your other tools, like Slack, just keep working perfectly. And second, speed. The host can now talk to multiple tools at the same time, running tasks in parallel. And what that means for you is that you get answers and results dramatically faster.
Okay, so now our AI can actually talk to the outside world. That's awesome. But what can it really do? This is where we introduce the concept of primitives. These are the actual offerings, the superpowers that a server gives to the AI.
Let's break down these superpowers, shall we? First, you have tools. These are all about taking action. Think create a new Google Doc or send a message in Slack. Then there are resources, and these are for reading information. This could be anything from a simple text file to, the entire contents of a database. And finally, we have prompts. These are basically instructions that shape the AI's behavior, like telling it, hey, always respond in a JSON format.
Now, for all this communication to actually work, everyone, the host, the client, and the server, they all need to be speaking the same language. So let's pull back the curtain for a minute and take a look at the secret language of this entire ecosystem, the data layer.
That language is called JSON RPC 2.0. Now, don't let the name scare you off. It's really just a lightweight and standardized way for one computer program to ask another one to run a function for it. It's the grammar and vocabulary that holds this whole system together.
And here's what that conversation actually looks like in practice. The client sends a simple JSON request, basically saying, hey, can you run the tools/list method for me? The server then sends back a response with the result, an array containing the available tools, which in this case are find issues and create file. See? It's just a clean, simple, and standardized conversation.
So you might be wondering, why this specific protocol? Why not something like a standard REST API? Well, for these kinds of AI applications, JSON RPC is just a perfect fit. It's incredibly lightweight, so the messages are simple and fast. It's bidirectional, which is huge because it means the server can also send requests back to the client. It's also transport-agnostic, and we'll get to what that means in just a moment. And on top of all that, it supports batching to send many requests at once and notifications for these fire-and-forget type messages. It's just built for this kind of dynamic conversation.
Right. So that transport-agnostic part is absolutely key. The language is what is being said. But we still need a way to actually deliver the message, right? And that is the job of the transport layer.
And the delivery method we use really depends on where the server is. If it's a local server, maybe running on your own machine to, say, access your file system, we use one method. But if it's a remote server, like GitHub servers out there on the internet, we're going to use another.
Okay, so for local servers, the transport is something called STDIO, which stands for Standard Input/Output. Since everything is happening on one single machine, the host can just talk directly to the server process. This is incredibly fast, it's super secure because there are no network ports open, and honestly, it's really simple to implement. Now, for remote servers, we obviously need to use the internet. So we use HTTP, the protocol that basically runs the entire web, for that universal reach. And we combine it with something called server-sent events, or SSE, which lets the server stream data back to us. This is perfect for long-running tasks, and it gives you a really smooth, real-time user experience.
Okay, we've covered all the individual pieces now: the host, the client, the server, the primitives, the language, and the delivery. So now, let's put it all together and look at the full picture of this elegant, unleashed AI architecture.
And here it is, the whole shebang. It all starts with the host, which can talk to multiple clients at the same time. Following the flow, we see each client has a dedicated one-to-one link to a single server. That server can either be local, running on your machine with STDIO, or it can be remote, across the internet via HTTP. And the entire conversation, from end to end, uses that universal JSON RPC language to access the server's powerful offerings, its tools, its resources, and its prompts. This is the elegant architecture that sets our AI free.
And look, if you take away just one thing from all this, let it be this. The real genius of this whole design is the complete separation of the data layer, which is the language, from the transport layer, the delivery method. What this means is that you can use the exact same JSON RPC messages whether you're talking to a tool on your own machine or a server halfway across the world. That flexibility is what makes this so incredibly powerful and future-proof.
By solving this communication problem in such an elegant way, the Model Context Protocol has truly unleashed AI from its digital box. It can now interact with all the tools and data in our world. So, the big question is, now that AI is finally unleashed, what will we build next?